of students are outside maybe, because I see, am I right? So maybe they went, I don't know. But it's the morning time. There should not be any. Anyways, how are you? I just summarized the last lecture. We studied two things. You remember, I'm not going to talk because that was introduction, okay? We can talk anytime you come to me, but in class we have very little time. And I will not go out of the class. Usually my habit is to talk too much. Nobel laureates and no, we do not have time, really. Wallah, if you like anyone who likes more knowledge, come to my office, okay? Just send a message or tell the leader, we can manage. I can come here if 10, 20 students, but we cannot talk much. That's my usual habit and wish and ambition, to talk much about what is going on in medicine, but it's not easy. So I summarized the last lecture into two sentences. We studied excitation and conduction of action potential. Excitation means action potential, basically. So production of action potential and propagation of it. Okay. Now the second thing this was electrical. This was electrical. Now the second thing was chemical, and that was axonal transport. That was also a neuronal transmission, but it was not from the one cell to other, just from the neuron body, nerve cell body, the soma, to the dendrite, the branches of the axon are back from the body skin to the neuron. So it was just in a single cell. So it's difficult to say it was neurocommunication. Neurocommunication means the communication, we are talking each other. This is communication. If I'm doing something and with myself, it's only one cell. You know, when several people talk with each other, this is communication. Risala, is it? The messaging, neurocommunication. So today we will study neurocommunication. Okay. So I think you should have very clear concept. The contents and knowledge, everything is okay, but you must know what you studied, what you are studying. If you do not understand and you get the confusion of terminologies, no faida. Please. So at your level, it's very important. You must know what you are studying, what you studied. We say siyaq wa sabaq. You say in Arabic? Siyaq, sabaq is difficult word. It's Arabic. Means what we studied before, what we will study after that, connecting with each other. Then you understand what you studied after intermediate. The first year, second year, third year, all knowledge. What you will study onward, you become doctor, then FRCP, higher specialist. So all those things in combination is called as siyaq, sin, ya, alif, qaf. Sabaq, sin, be, alif, qaf. This is Arabic. So anyways, some are very difficult words. To the context, previous and the coming. I again repeat, we studied in the last lecture, this is important to know, how the action potential is formed, is developed, how the action potential develops, and how it travels. Simple. Plus, we studied how the chemicals, exoplasm is a tube, axon is a tube, right? So, from the body, cell body to the human body skin, it's a tube. And what is inside the tube? Protocol. I mean, you should know. Don't become confused. Exoplasm. Oh, no. Exoplasm means the protoplasm that is present in axon. Simple. Don't get worried. It's simple. Actually, I talk for all students. So sometimes I make too much easy. Maybe you will be getting very feeling strange. I'm going so low level. But I'm teacher. It's my responsibility to put the ideas into each of your brain, right? So it's difficult only to talk difficult things. Sometimes I talk very little things, okay? Because there are a variety of the students, maybe some people do not know. So what is exoplasm? Please tell me. Cytoplasm that is present in axons. So through the axon, through the flow of movement inside this tube, the substances either go anterograde or retrograde, orthograde or retrograde. Simple. I think we can say that. Okay. And which things go that are needed for physiological functions? Number one, that are needed for the other people who got like viruses, bacteria, and they also use the same route. Because when you make a road, the good people and bad people, you cannot say don't go this road, you are not a good person. Huh? It's not fun. So all people, because when they go inside the body, they live for a long time and they become the part of the society, and people know, hello, how are you? And some people introduce to them, this is my new friend, but very dangerous. The day this new friend expresses, then the body knows, oh, who this is, virus. You got it? So the thing is that it's very clear. Now the third point is this neurocommunication. Did you get my point or not? One thing is production of action potential. Second thing is the transmission of the substances through axon. But both things are incomplete until we talk how. This is actually a part of neurocommunication. When you say action potential is produced, it travels. We talked about the single cell membrane traveling. We did not talk about other things, though we talked about a little synapse in this. But now today we will talk totally how the message action potential are through axon, chemically, electrically, you can say electrochemically, how the message or impulse, chemical or electrical, goes from one cell to second cell to third cell to inform everybody in the body. This is called as neuronal communication. I cannot stop myself sometimes to give you general knowledge. One of my teachers, Professor John Eccles, he was a Nobel laureate, Australian Nobel laureate, and he was the person he discovered first of all that electrical current connects two neurons. Before even his teacher, Sherrington, you know, Baba Physiology, he was in 1850, 60, the last century. The Baba Physiology, Sherrington. So John Eccles was the student of Sherrington. John Eccles is the person who used the terms pre-synapses, post-synapses, synapse. These terms were used. He was very brilliant. He got Nobel Prize also. I think in 1901 or 2. Please go and check it. I don't remember. You can check that. He got Nobel Prize. He was a very pioneer. But one of his best students from Australia, he did wonderful work following the lines, ideas of Sherrington. And this person was John Eccles, the best neuroscientist in this. But he also started research in 1890 or something. But he died, I was in Toronto, my first postdoc, 1996 he died. I remember the day. So, yes, I was telling, this is good, sometimes you should have some knowledge, but I will not go in detail. He introduced electrical communication, and he was the person, he thought the communication only occur electrical, no chemical. Initially we do not know. With the time people do. He did not believe. But when other people discovered other things, they started believing this and that. Oh, he came to believe. Otherwise he was initially not. He was following his teacher. His teacher's name was Popper. Popper was a philosopher. And philosophically they came to conclusion that our whole body is communicated only electrically, because they found electrical current in brain, and they thought the ideas are converted into current and current flows, and this is the whole story. No. It was half story. So electrical communication, so electrical synapses he believed. He did not believe chemical synapses. So later people discovered that chemicals come upon the surface of from one cell to other. Though his teacher said pre-synapse, post-synapse, synaptic gutter, synaptic cleft, but still Eccles, he was the first person who discovered that this is the current that connects to neurons. This was a big thing, and he got Nobel Prize. And many other things he did, but this was a very, people in electricity, electrical engineers and physicists did much work. What is electricity? Okay, it was discovered, but it was not discovered that body neurons are connected. They talk with each other through electrically. So he was a pioneer, no doubt. but chemically. Now we know the I don't stop more, okay? We don't have time. The neurocommunication is electrical and chemical, okay? There is no doubt now there are many neurotransmitters, even excitatory and inhibitory. If a cell, you understand presynaptic cell? One is, the first cell is called as presynaptic cell, the other is called as the postsynaptic cell, and this is the presynaptic cell, and this is the postsynaptic cell, and this is cleft, synaptic cleft, and this is synapse, this area, the empty area plus a little more. So this is the functional area, where one cell communicates to other, and this functional area is called as synapse. Yeah, sure. Same thing. Synapse. What is the name? Synapse. So the things are here. I mean, this is coming from the brain. So brain, inside the brain, the neurotransmitters are synthesized. For example, adrenaline, excitatory and inhibitory both. Clear? Now, but they do not come like in molecular form. They come in a bags. If you go to market, Zellers, what is the name? Whatever. Bin Dawood. They will not give you sugar like one piece. Take it. 1 kilo sugar will be in some pot, right? They will not throw. Take this. It's very difficult. So the neurotransmitters come in the bags. These are the sugar particles, not sugar particles. I mean the stuff. Now all these bags, you can say vesicles or bags. Now, we will talk today how these are formed, how these are broken, when these are broken down, why they are not broken down all the time, what is the stimulus that break them, and how these acetylcholine come out, or if it is excitatory cell, acetylcholine. If it is inhibitory cell, then GABA or something. If it's excitatory cells, they will go and combine with sodium channel. I mean, acetylcholine is related. So if it is inhibitory GABA, then it will combine with chlorides or potassium chloride. You understand? So this is the way of nature, how the physiology works. The physiological regulations are very different from usual or whatever we do in the world. It's very, very natural and very perfect. It's very different regulation, okay? So excitation, and if you have to decrease inhibition, you add excitation into inhibition. If you have to decrease excitation, you means body. If body has to decrease excitation, it adds inhibition into it a little bit. How much? It depends. So this is the Subhana. It's really, maybe I don't know how much you understand, but it's wonderful and it's very interesting and Jamil. So how the inhibition goes, how much? Maybe 2%, maybe 0.01%, maybe 10%. It depends upon how much is needed. So this was the concept of synapse. Now this is neurocommunication from one cell to other. Now I think we should go step by step, otherwise we will not we have another lecture, right? So till 11 to 12, and after that you're free, I think. But I will not take time, maybe 5-10 minutes. It's okay? No, 12 o'clock lecture? Oh really? There's a lot of time. Yeah, you have some like but that's good time, I love that because I can talk with you, you can come and ask questions. But we will not take, like yesterday we took much time, maybe you didn't do your lunch, and salah, everything important. I also talk sometime when I put too much in your brain, maybe you get tired. So this is philosophy of the teacher talks, enjoyment, some discoveries, John Eccles, so you are fine. Everyone is fine? No one is sleeping, huh? Physically sleeping, okay. So you like my way? Yes. Because my purpose is to convey, to give the knowledge. And you think and you arise questions. Only these slides, no, you have many books. Go home and study. The basic concept, what I learned whole life, I have to transfer to you as a new generation. And this is my purpose. So then you will convey to others and others. This is a silsila. So this is basically the purpose. Okay. Now see the learning, I think objective we read at the end of time. lecture. Is it right? Because the terms will be difficult for you maybe. So it's better we discuss later. You already have lectures you have studied. Outlines we will study today, neurocommunication. So synapse is a structure that is very important for neurocommunication, and the synaptic potential, temporal, all the actual potential are summated and then they go. Either say summate from different places, space, makan, different makan, they combine. This is called as, what is called spatial. Space means makan, okay? And if it is like one action potential arises at one time, after 10 milliseconds, after 20 milliseconds, temporally, time-wise, makan and zaman. This is now zaman. So the body collects, summates the potentials, activities, electrical activities, according from different places, spatial summation, or at different timings. And now, after few milliseconds, after 100 milliseconds, they also, this is called as according to zaman. You say zaman, okay? And in English, what we say? Temporal. Temporal is from time. Time. Okay? So time and space. Huh? Space and time. It's right. Makan was zaman. Okay? So the neurotransmitter receptor, we will talk about these, how the integration is. So there is no doubt today we will only talk what is neurocommunication and how it occurs, what are the fawaid, of this, and sometimes what happens in nuksanat when the things get disturbed, pathological. So normal enough. Okay. So this is first sentence. Now tell me, I think this is clear. The first sentence, I don't think you have any problem, okay? Presynaptic and postsynaptic, who used these terms? Professor Sherrington, first time. Presynaptic cell, presynapses, presynaptic membrane. That is the presynaptic membrane. This is the presynaptic membrane. Why we say presynaptic? Before. Because this is the first term. It comes before the second. So postsynaptic membrane. The receptors are here. Vesicles are here. Though neurotransmitter, you have studied in first year, second year. I think sometimes we don't need to talk more. But you should let me know that this is not clear. Really, very frankly, you tell. But I think in second year you studied. So the types of the synapses, very simple. If axon combined with dendrite, are you getting? Yes. Axon is long and it goes to a neuron, and dendrites they're combined. So exodendritic synapse cleft. Or if the axon connects with the cell body, exosome, mashallah. And if two axons combine with each other, okay. And if dendrite and dendrite, two and dendrite combine, dendrodendritic or dendrosomatic. This is you can understand. This is simple. Is there any question?
So all part of a neuron can transmit.
Mashallah. The dendrites take the information, and the axon give back, convey the information in general. But when dendrite and dendrite are talking to each other, anything is possible. They are the neighbors. They can tell, there is a danger. You know what boss told you? Didn't do that. They talk too much. You understand? They do not talk, okay? It's good for you to understand, but they have behavior. We cannot say they are just like us, okay? But they know better than us. They are better scientists than us. Anyways, so nicely the system is going on, and even we don't know. Autonomic nervous system. Okay. One is central nervous system. I can bring my hand here. I can write, I can talk. This is central nervous system. Skeletal. But whether is my digestion is going on, my heart is working, everything I don't know. This is autonomic nervous system. Okay, go ahead. This page is okay. Any question? It's simple. I should not miss any page. If I miss, just click in, let me know. Now I told you, Professor John Eccles, the student of both are Nobel laureates. Professor John Eccles, the student of Sherrington, he said synapses are only electrical. Why? Because neurons are connected only electrically. Later it was proved wrong. So Nobel Prize people can also do mistakes. Human is error. So humans, deficient knowledge. When you sit with the Nobel laureate, you will know each and everything they will say. I don't know. Professor Sherrington one day said, I don't know who we are. I tried very much to understand, I could not understand it all. And same if you read the book, there is a very good book of John Eccles. Its name is Facing Reality. He was a scientist, but later, when he was old, he wrote a book, philosophical book, but it is neuroscience book. Cognitive neuroscience. You understand? Maybe you will study, in the next semester. The fourth year, first semester, you will study neurology. I hope if I'm with you. So neurology is interesting for me. And after that, second semester, you will study psychiatry. So both semester, coming semester, the fourth year, first and second, you will study that. So what I was talking?
Electrical synapses.
So he came to conclusion that synapses are only electrical, but later he knew. No, I was saying that even Professor Sherrington said, I don't know who we are. He said, I tried but I could not understand anything. See that? A Nobel laureate says, I know nothing. Jahula. Okay, so I don't know how much you understand. Sometimes I say quickly. But what John Eccles said, same sentence, but he said, I tried to know, but I couldn't understand. Who am I? Something said. Mine could not. It's not easy. The understanding self, it's not possible for me. We are doing this. It's la mutnahi. You understand? La tanahiya. I don't know what you say in Arabic. I think something is indicated. Okay? So the electrical synapses you got, where they are formed? Where chemicals are not involved. There are some cell connection with each other or inside, like gap junctions. There is no any chemical. Only the message has to jump from one side to other. But there is no any chemicals. This was the reason Professor John Eccles got confused. He saw whatever he studied. He studied much about sensory and motor physiology this whole life. But maybe he got confused when he saw the gaps. There is no chemical. So he thought if chemical present or absent, the real mechanism is electrical. This was a confusion. No, but he was wrong. Later he corrected. In his life he corrected, I'm wrong. So electrical synapses are where there is no chemical involvement, only current jump from one side to another. So in any pathological studies, if you find such thing, now you will try to understand electrical synapses, okay? With that time, inshallah, you know it, because we cannot go in details of the applications at this time, but next year, inshallah, when you will study neurology or psychiatry, we will give examples with the medical disorders. So is it it's written? Less common than the chemical synapses. And they correspond to gap junction. You understand? Only junctions. There is no chemical. So the electrical current, electrical message jump, electrical potential jump from one cell to other. Clear or not? Okay. And they are important in certain. See how much important they are. And John Eccles was doing too much work. Actually, he was working under a philosopher, Popper. He was a big philosopher at that time. He got, philosophically, ethically, they go in many things and very logically they interpret. Okay? So he was more interested to understand what is arousal, what is consciousness. We will study the last lecture, the physiology of consciousness, right? My last lecture. So he was more studying consciousness. What is in Arabic? Shu'ur. You understand shu'ur? Understanding self. Shu'ur. So what John Eccles says, who am I? And Sherrington said, who we are. So if you get time, please read that book. It will be there. Your library is the best library, one of the best libraries. Really, I go usually. So please go. You should go. You must go sometime. The name of the book is Facing Reality. I can write if you say in the message. I can tell you the book. So they are important in. If you are sleeping, how you will come back to arousal. So this is involved. We don't go in detail. Okay, I'm sorry for that. Very interesting, but no time. And you study mental attention. I'm not intended actually. I'm thinking something you say me. I quickly orient toward you. So these are electrical synapses. I mean, always not chemical synapse involved. Sometimes only electrical synapses plus chemical also. And emotions, I become happy. Oh, you got the very big prize. You will go UK. How much happy you will be. Or if something happens with someone dies, we become depressed. Depressed, something, emotion. So emotions also relate to that, and memory also. Really, it's interesting to study more how it happens. And ions and water homeostasis, this is full physiology. So it means electrical synapses are much related to physiological processes, not only neurophysiological, physiological. Okay? Is it clear? This page? Children, any question? Anyone who is sleeping or using cell phone? Mashallah, your cell phone, this one big. No, something else. No, but you see here, okay, whatever you like, but the best is to see this really, Allah, talking with each other and seeing this is enough. But if you think you can see other things, yes, sir. Any question? I need questions, please, yes.
The emotions considered with the chemical concentrations. How is it?
No, I will combine, because the next slide will come chemical synapses, then electrochemical. We will discuss. Inshallah, you keep in mind. We will discuss. Good question.
The emotions and memory and most concepts of behavior are included in the
Behavior. Actually, chemical synapses are definitely involved. But for a transient period, sometimes if something is jumping, connecting two parts just by gaps, then electrical. So it means electrical. We do not mean only solely electrical synapses. No. Chemical. We say electrochemical. This is reason nowadays we don't say electronical. We say electrochemical impulse. We don't say electrical. Yes. You got it?
Usually electrical synapses jump from cell to other.
Yeah.
What is the
Did you study in second year the junctions?
force?
No, just the structural junctions. The membrane junction. There is no any chemical, no structure inside.
No space?
Yeah, no space is there. Makan is there. Without makan,
I mean electricity, how do you
electricity jump from one conductor to other conductor. One cell membrane is conductor, the other cell membrane, there is a gap. You can think Hubli, or bridge. So from this side to that side, you go through Hubli. Okay? Imagine this is electrical. It's not chemical. You got it? Okay, good. But with the time you will know it in the slide. Yeah.
So, doctor, in unexpected events or surprising effects, our body responds with electrical synapses, not chemical synapses.
Actually, for bit period, electrical synapses are very little compared to chemical. So they work together. For example, if initially people discovered that electrical current is flowing around the axon, but later they knew in the axon there are chemicals hand in hand. Same time they are also flowing. So the process is electrochemical. The process is electrochemical, but there are some processes where solely the things happen only by electrical. Electrical engineering is there. Electromechanical, electrochemical is in reality whole body, but sometimes some functions are solely, those are called as electrical stuff. No involvement of chemical. But most of our synapses are both electrical, subhanAllah, and chemical. They go hand in hand. And we don't know much about the saltatic reduction and the movement in the axon. Is there any relationship of chemical with the current? I don't think people have studied yet. Maybe you people will study. It's a good question. Really? So electro, now we say electrochemical, okay? But there are still some synapses completely electrical. You know? When they have to make very fast activity. Okay? And also in electrochemical, if too much fast, then myelinated. Okay? If not too much fast, then unmyelinated. Is it clear? If any child does not understand, please, no hesitation. I mean, you are just like, but you can arise any question anytime. If you do not like question to be arised, after class at some other time, but keep in your mind and let me know if you don't understand it. So this page is okay? All right. We have to see the time also. I put it here. 9:38. Okay. So we do not have much time because we lost 10 minutes, I think. Anyways, chemical synapses. Number 2. This is easy. You have studied maybe first year, second year. Specialized release receptor. I mean, the second cell, this is chemical. The second cell has receptors. The first cell has Vesicles. You understand vesicles? Excitatory or inhibitory, and typically composed of two parts: axonal terminal of presynaptic neuron, which contain vesicles, right? And the receptor region in the postsynaptic part of neuron. It can be dendrite, axon, exodendritic, dendrodendritic. What else? Exosomatic. It depends. So anyone who is the first will be called as presynaptic. Anyone who is the second cell where action is happening, postsynaptic. So presynaptic cell, then presynaptic membrane, same thing. Actually, membrane takes part, not the whole cell, but the things are in the cell, like the vesicles, the pegs. They are not in the membrane; they are in the cytoplasm. Is it clear? Yes. Okay. And this page is gone. It's simple, but still you read it. If you find any word, you let me know. I sometime you will see in this lecture, in the very short, like 20, I wrote some explanations. So you can quickly write, or even you can go home in dictionary, but that's not included in your exam. Just to give you what this is, definition. The lectures were sent to you, right? But they don't contain sometimes some difficult term. If you put each and everything, it will be 100 pages. It's not good for you, okay? We will include everything in your exam, and you do not have too much time, right? So the slides are only 20, 30, but others I added a little bit, not much. Okay, now synaptic potential and neurotransmission. Between the two cells, this area that is empty, this is called a synaptic cleft. Is it clear?
Yes.
What is it? Synaptic cleft. It's written there, synaptic cleft. Termination of neurotransmitter effect. Okay, when this neurotransmitter comes out, the vesicles are broken down. It attaches with the receptor. It works first. The time the work is in process. For example, I'm walking. When I'm not doing work, it will be finished. No more binding with the receptor, right? So the receptor, will not. So this is called as the termination of neurotransmitter. Clear? No more effect of enzyme, because we are not working. Enzyme effect is needed when we are working. Message is needed when we are working. We are not working action. Why action potential will be produced? Why it will be transmitted? This is resting condition. Okay? And then the synaptic delay. Synaptic delay means time needed to do this. All this process of formation of these vesicles breaking down, I will discuss how it is breaking down. And the action, occurrence of the shovel, the work, how it is done. This takes how much time? 0.3 to 5 milliseconds, okay? And postsynaptic potential are two types. Okay, if that vesicle is excitatory vesicle, what it means? It contains excitatory vesicle. Then the potential form will be excitatory postsynaptic potential. Why we say postsynaptic? Because this occurs upon the postsynaptic. The things, vesicles are in the presynaptic cell. They come out from the presynaptic, where they will sit on post. So definitely potential occurs, potential changes, action potential on the post. So postsynaptic potential. It is excitatory EPS. If it is inhibitory GABA, what will be the name? Inhibitory IPSP. These are easy. Don't get confused. Okay? These are very simple. If you have any confusion, let me know now or later, anytime. So next slide. Don't hesitate, tell me any time, now or another class or any time. This is very interesting, really. It will now give the real idea how excitation occurs. I tell you, in our body, this is wonderful. I will not talk much one sentence because I wish, and sometimes I wish too much to let you know more things, but we don't have time. But our not only our neurophysiology, but our whole physiology. Physiology, as I told, is a Nobel subject. It has no area, like the chemistry has molecule, biochemistry, biomolecule, physics has radiation, psychology has self. Similarly, mathematics, you know that, physics, but physiology, you cannot say what physiology is. If the physiology is the nerve, then neurophysiology. If the heart, cardiophysiology. If the cellular physiology, histophysiology, right? System physiology. If behavioral physiology, clinical physiology, ecophysiology, whole animal, plant physiology, bacterial physiology, molecular physiology, biophysical, And people are thinking about the atomic and electronic physiology, and in the next century, the new terms. So it has not any, it studies as a whole. This is physiology, understanding function by integrating all levels of specialization, from the wave up till psychology and the ecology. So this is very complicated. This is the reason the Nobel Prize is given in physiology. I give you a basic concept so that you think in future. Excitation, if it becomes abnormal, there are a large number of group of diseases due to disorder in excitatory transmission, excited neuron. Similarly, inhibition is disturbed, inhibitory diseases. Okay, excitatory are mostly like epilepsy or something excitatory, hyperexcitatory, and inhibitory like you go in depression. So diseases, your whole pathology, your whole medicine can be divided by excitation and inhibition. But it is not only the neurophysiology, because cholesterol, fats, proteins, everything gives either excitation or inhibition. So this theory is not neuroscience, this is physiological theory. So balance of excitation and inhibition is life. I mean, there are many ways to explain, but physiological interpretation is the balance. If there is any imbalance, this creates disease. So what is normality? What is abnormality? What is physiology? What is pathophysiology? What is the just normal biology, and what is medicine? So this is a big theory, okay? So it's not only, did you get it? So this is a thought for today. Now you will think how it happens, how many diseases you go home and study. But here, this left side, yasar, is the excitation. And yamin, what is it? Okay, so see, in excitation, neurotransmitter come out. Clear? Vesicle is broken down, neurotransmitter come out. What happens? Sodium channel in the postsynaptic cell, sodium channel open. When sodium channel will open, what will happen? Sodium will go in. When sodium go in, what we say? Depolarization. When depolarization, but it is only local. It is not spread locally. And presynaptic or postsynaptic? Postsynaptic. And this is called as, and resultantly, activation and excitation will occur. And the potential form will be called as excitatory postsynaptic. It's not excitatory presynaptic. Potential is occurring on the membrane of postsynaptic cell. Clear? Yes. Now in inhibition, see, inhibiting, for example, GABA. GABA will open chloride channels, not sodium. Because more chloride will go into cell, will make more electronegative. More is electronegative, more is toward depression, inhibition. If our membrane is more negative, inside cell is more negative, we cannot produce action potential, very difficult. But if it is less negative, in the first case it is less negative, so depolarized. In the second case it is too much negative, maybe 120, minus 120. Now from minus 120 going up to threshold, it's not easy, very long distance. So inhibition level.
For the potassium, what happened?
Potassium is that potassium will come out. So again, negative chloride will remain inside. Or if potassium is attached with any negative ion, more negativity will be inside. More negativity means more action potential. You got it? So potassium and chloride both have similar function. Coming out of potassium or going in of chloride, both have same function. You got it? Yes.
So we have sodium inside?
We are not talking about sodium. Because the first case sodium influences. Because when depolarization can sodium go in. When repolarization occurs, sodium is stopped. Sodium gate is stopped. Sodium does not go. Now we are talking about hyperpolarization. I mean, so many positive ions are going out. And membrane is becoming from minus 70 to minus 80, minus 90, minus 100, minus 120. This much, this. It was basically this one. It was easy to do action, this much. This is the mechanism of our memory cells have this type of cells. So whatever you do, you cannot produce action potential in memory cells. Allah subhanahu wa ta'ala has made perfect memory. We just stored whole life. In the body, you stimulate too much. So cells have many types. And this is hikmah. Fawaid. Some cells are very high, they remain at minus 120, minus 100. Some remain as minus 70. Minus 70s are workers, they quickly do work. I'm talking whatever they do. But the very, very it means we do not get excitation because we need to store information. These are very important things, okay? Did you get it? This is called as inhibitory postsynaptic. Is it clear or not? Yes. It is continuous on this next slide. Now, when the excitatory synapses of one cell, second cell, third cell, they combine with each other, what you said, summation. So summation will be temporal or spatial. I thought already. I mean, in different timings, temporal. I mean, zaman, temporal. And different places, all the potential together, makan, spatial. So action potential in the postsynaptic neuron occurs, and this is called as excitation, real, fully. And that is inhibition, because inhibitory potential, inhibitory means the potential that do not allow the action potential to occur. So it means the stoppage of electric activity. Sometimes our body has to stop the action activity. Sometimes it has to keep it continuing, right? So both these functions are called as excitatory inhibitory. I did not go in detail though. We can discuss maybe many lectures, but I'm sorry. You read it. Anybody who needs more knowledge, come to me. Okay? Yes, yes.
You mentioned that GABA causes the chloride channel to be open. Can it cause the potassium channel to be open?
Actually, there are variety of channels. I did not discuss many. GABA is also GABA A and GABA B. One opens chloride, another does not open. And there is also a potassium channel that opens potassium. Actually, I did not go in details. So this was easy just to mention that if sodium go into the cell, it's an excitation. And you know depolarization. Usually we discuss depolarization. At your level, we do not. Otherwise, it will be very confusing because there are many calcium channels mainly involved. So what are the changes reciprocally with the sodium and calcium? It will be confusing. At this level, it's good for you to know if sodium go into the cell, depolarization. If potassium goes out, potassium means due to potassium channel. Okay, and chloride means chloride channel. But the neurotransmitter is not only GABA for chloride, and not only the sodium potassium is the acetylcholine or some adrenaline. There are many. So this is the beauty of the body, that we are giving an example, but anything that can depolarize, that can bring sodium into the cell, it causes excitation. So it is not only acetylcholine. In our body, there are even one neurotransmitter in one area can cause depolarization, in another area can cause hyperpolarization, depolarization. It's a very complicated story. So you will see some neurotransmitter, you cannot say they are excited here. They work both sometimes. Sometimes receptor things attach with receptor, excitation occurs. Sometimes inhibition occurs. So when you will study medicine, pharmacology, more and more you will know what are the varieties of those. But it is a nice question. Anytime you can come, we will discuss more, but not here. Okay, and this is done, this page, and I don't know what the time is running, 8 minutes. Is there a class after that? Yes. Maybe the teacher will not come? No. We should pray, we should come. But I'm just joking, okay. So, very quickly, what are the factors that affect synaptic transmission? You know, if the blood pH, if it is, see this word alkalosis is not written in your notes, okay? You can write down, it's okay if you alkalosis means if the pH become 7.4 to 7.8 or 8, you understand? So excitation will increase. If it becomes acidic, like 7.4 is normal, it becomes 7, and then excitability will decrease. So pH influences. Hypoxia, you know oxygen, it increases if you do not go outside, always inside the room. You must go in the park in the evening or morning time to get more oxygen. And if you do not have enough oxygen in your body, it will create a little hypoxia. A little, and that may cause a neurotransmission problem, and in the long run may cause any neuronal disorder. Be careful. So you need, after hayat, the most important thing is oxygen. We cannot go in this topic, it should be a full course. Hypoxic physiology or ischemia, physiology of ischemia, is a huge topic, but you must take daily enough and the best is exercise. If you do not do exercise, at least walking or jogging, it's must for your life to control your glucose, everything, and oxygen, enough oxygen in morning after Salah, it's I think the best. Salah Fajr, you just 10 minutes, 15 minutes, go in the park and walk fast. You store huge oxygen. It will be good for holding. So if you sit in the room, from home, room, here, room, all AC, no, air is coming, but you may get a little deficiency of oxygen, okay? And this can cause increasing and many disease, epilepsy, any. Yes, please. Yeah.
How occlusions can cause hyperexcitation?
Actually, this is a very complicated topic. I will suggest you to come to me. It's a very interesting full lecture. Basically, the hypoxia or acid. Hypoxia or acid. I think you come to me because it's a long story. I think we are finishing. How many? 5 minutes? Please come to me. Yesterday you came, mashallah, he has huge knowledge. We will talk, but when you have enough time, not 5-10 minutes, more. It's very interesting, but it is not in your level, okay? And it is my interest, my interesting area, okay? And then when the hypoxia and pH change, what effect occurs? Excitation increase. Number two, some tea or coffee or something?
Yes.
You know, you become active. And similarly, theophylline, theophylline. Strychnine inhibits inhibitory means it excites. If inhibition is inhibited, means excitation occurs. It's a complicated sentence. And it excites. It inhibits the inhibitory effect of stick. Okay? Did you get it?
Yes.
And similarly, drugs that decrease the synaptic transmission. I think in the last lecture there was a case. And by the anesthetics. I told you, you do not know if you go to the dentist and get teeth out or whatever, and you will not know what is it. Well, this is anesthesia. They make the neuronal membrane less responsive to excitatory agent. And this is the reason depolarization does not occur. And sodium cannot go into the cell. Did you understand? The very unfortunate thing is we have very little time. I think maybe 4 or 5 minutes. Very unfortunate, and the topic is very interesting. Okay, this page is gone. I don't know. Oh, this is just general. If you say I can send to you, whatever I talked about classes is for you. I will send to you. I will send to the leader. This page is for you because maybe you have time or not to come to me. So this page will help you. You can get photo of this page. This is not in your course. But this is, see, he asked question already, the things were ready. This came in my mind, you will ask this question. But I did not go in detail, okay? I'm sorry, just a little bit, because your level is not. So whatever I talk is written here. Whatever I talk, the pH and all acidosis, acid, whatever I talked with you is written. But the question is how it happens, it is not written, okay? It's not mentioned here. So this page, you can get it. It's easy. Otherwise, I can say. But it's not included in your code. So this is the same thing I told you. The synaptic mechanisms. 3 minutes. So how many slides we have done? So next time, please, we will request the teacher to go out. 10 minutes were enough to finish. We lost initial 10 minutes. Your teacher apologized, but apology is not enough. Loss is loss, okay? So this is 30. Now see, we have to finish this lecture and the next and the next. I will take more time. I'm sorry for that. Is it okay? I will not take, but the next lecture we will go quickly. So this is conceptual and it will take around 10 minutes, not more than 10. Okay? So I should finish because next teacher is coming. How many minutes are there? 3 minutes? Okay, 2 minutes. We finish this. Come on. Okay. What is this? I don't know. Okay, so this is easy. Whatever I discuss, listen, children, quickly in 1 minute. First of all, action potential depolarizes. Then calcium go into the cell. How it depolarizes? This is a question. Calcium go into the cell but through the depolarization of calcium. When calcium, why calcium go into the cell? To break the vesicles. When calcium goes, how it breaks, we don't go in detail. But when calcium go into the cell, the vesicles are broken down and the neurotransmitter diffuse from the membrane upon the receptor. See that? And we discussed all that before that. This small figure we discussed, and no more. Okay. Yeah. Inshallah, at 11 o'clock I will come. Okay. Are you okay? Inshallah, 11.